All right, welcome back. So today we are going to do a problem called unique paths. So this problem is actually quite similar to some of the previous problems that we've done before, like for example, climbing stairs and stuff like that. But that should give you a little bit of spoiler, but let's just go on to it. So the question says, a robot is located at the top left corner of a M by N grid. So here's the robot. Good thing that they drew it for us, so now we understand. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, marked finish. How many unique paths are there? And then that's pretty much it. I think that's the question. M and N will be at most 100. Okay, cool. So that's good. So let's take this an example and let's see what the number is. Actually, let's take this example, 3 and 2, right? So M is 3, right down. So it probably looks something like this, 1, 2, 3, right? And then the robot is right here. I'm gonna draw a smiley face because I don't know how to draw a robot. Yeah, so imagine the robot is here and the finish line is here. So basically what they're saying is that given this matrix, this size matrix, 3 times 2, how many ways can you reach here, which is the end state? So there's actually 3, and I'll do it in 3 different colors. There's this one, where you go right down, or there's this one. Remember, it can only go right or down. It cannot go up, it cannot go left. And then there's also this one, right, down, right. Right, so then there's no other way. There's 3 ways, okay? So how do you do that? Let me think. So I guess the way to think about this is, how many ways is there to get to the end? And then you try to go backwards. Try to go backwards in terms of your thinking. Imagine we have a robot here and we have a star here. Now let me ask you a question. How many ways is there from here? Imagine we are here, this robot. Imagine the robot is here. How many ways is there to go to here? Actually, you know what? Let's make this even more simple. Imagine the robot is here. How many ways is there to get to here? Let's call it star prime. So this should be pretty obvious because you can only do it this way. There's no other way. So let's put a 1 here for now. There's 1 way of getting to this star. Imagine if this was a star, right? So the question was, imagine if the size was 3 times 1. If that's the case, then the answer would be 1. What about here? Prime. How many ways is there to get to here? Let's draw blue. Prime, blue. So there's 2 ways, 1 and 2. The first one you go right then down. The second one you go down then right. So if the size is, let's see, 2x2 equals 2, right? So the question is, given that you know these guys, given that you know this guy and this guy, how many ways is there to reach here? Let's make it red. So how many ways? Given that you know here on top, it's only 1 way you can go here. And then here, there's 2 ways. I forgot to write 2. Then obviously what that means is that since there are 1 way of going here and 2 ways of getting here, and then we could just add these 2 to get here. So we got 1 way plus 2 ways equals 3 ways. So that's another way of calculating it, right? Now what if the example is harder? Let's look at the screen here and let's do the same thing, okay? So they have 3 here, and then vertically they have 1, 2, 3, 4, 5, 6, 7 columns. 1, 2, 3, 1, 2, 3, 4, 5. Damn it. So ugly. Okay, so now the robot is here, and the end state is here. So we could do the same way. How many ways is there to get to here? And how many ways is there to get to here? Right? So this time it's not so easy. The reason why it's not so easy is because there's a lot of ways to get to this point or this point. Okay, assume we don't know these points. How many ways are there to get to this point or this point? Because we're trying to solve this one now. Now this one should be easy because it's 1. You know that because there's only one way of going forward. Okay, so that's how we backtrack, and then in the end, we can get to the right information. So let's think of it this way. What are the easiest ones to calculate? Right? The easiest one to calculate is the ones right here, actually. How many ways is there to stay at the same place, which is this position? Well, there's 1. How many ways is there to go to any of these squares? It's always 1, because you can only go right, you can't go down, because once you go down, you can't come back up. So here, there's always only 1 way. What about bottom? Oh, 1 way also, because you can only go up and not sideways. So then, what is this answer? And then given this answer, I think I'll be able to get this one, right? Let's just get this one first. Remember what we said here, over here? We just added the left number and the right and the top number. We could do the same thing here. So this one, add this one. What does it give? 2. Awesome. So now we're able to do this one and this one because we have our neighbors. So now this one would be 2 plus 1, 3. Now does that make sense? Yes, it does, because here it's also 3. And remember when we did the small example, this one? This one is basically a size 3-2. And if you think about it, this square right here is also size 3-2. And I get 3 here using my method, and we validated that it is indeed 3 ways to get there. So there we go. And then how do we get to the final answer? You just keep computing this. 4, 5, 6, 7, 3, 6, 10, 15, 21, and then this star would be 28. And then that would be the answer for 1, 2, 3, 4, 5, 6, 7. 7x3 size. Awesome. So what is the time complexity of this? Well, we have to calculate the whole table, and we have to go through all of it. And what's the size of the table? The table size is m times n. So that means the time complexity, because we have to go through all of it, is O times n, which is linear on the input. And then in terms of space, it is also O m times n. Awesome, right? Because you need to make this array. Now, if you realize, this is actually a very, very common technique. It is dynamic programming, right? So this is actually super simple. It's dynamic programming. When you think about it, it's the same thing as the question where we have the staircase saying how many ways is there to get to the end if we could go up by 1 or 2. This is the same exact thing. However, this time it's we have a 2D array to store our information instead of a 1D array. All right, cool. So let's code this up. What does that look like? All right. So first, what we want to do is we want to initialize the matrix. I usually just do it like this. I define a matrix, and then for each column, I add like n rows. So what I do is for I in range m, and then so m is like the first number, which usually here in the image, it means it's the columns. And then each column, there's a row of how many numbers, n numbers. So matrix append 0 times n. So that just means I have n zeros. It's like a whole column it's a whole array of zeros. And then there you go, you have your matrix. And then what we want to do is we want to set all the numbers that we know already, which is the ones on the side. We know that they're all equals to 1. So for I in range m, what we do is matrix I 0 1. So what you're doing now is you're setting the top row all to 1. And then you're gonna set the first column all to 1. Matrix 0 and then I equals to 1. All right. And there we go. So now you have, actually, let me just make it more simple. I mean, not more simple, more clear. J is for the columns. All right, cool. So basically what you're doing, let's go back to the iPad actually. So essentially what you're doing is first you have an empty array. And then what you did on the second line was that you added these guys to here. So first it becomes like this, right? Imagine you have an array and then you have another one, you have another one, and then you have another one. That's basically what you're doing, right? And then we could kind of visualize that in terms of a rectangle, right? And then they're all zeros, right? That's basically what you're doing. Okay, and then for the second line of code, or more like the second operation where we do for I in range M, so for I in range M, you set all to 1. So this becomes 1. Yeah. So you did this one equals 1, equals 1, equals 1, equals 1, and then the other ones are equals 1 also. So sorry, I didn't do that yet. And then the second one for J in range N, that's when you set these guys to 1. And then for the last line, or more like for the last operation, for I in range 1M. Okay, so now what you're doing is you're iterating through, let me put it in red, you're iterating through these guys, right? So what you want to do is for every column, which is like M, you do I equals, for I equals range that, and then J in range 1N, right? So that's just a double loop, very traditional, very classic. So then I, J, so that's just to point at which square it is, and then what you want to do is you want to compute these squares. And how do we do that? We add the top and the left one. So we add those together and you'll get the answer. So I, J minus 1 plus matrix I minus 1 and J. Now after you added all of them, you just return the corner, the bottom right corner, which is your finish line, your finish star. So you're gonna return M minus 1, N minus 1. All right, now let's run the code, see if that works. Wrong answer. Oh no, I might have done a mistake. Let's see, did I add it right? This should be good. For range I equals that, Okay, that's good. Matrix append, okay. Your input, output expected is 3. Okay, N minus N, that should be good. Let's see. Let me debug here for a little bit. Let me see if I read the question right. For 7 and 3. Okay, what happens if I put 7 and 3? It should give me 28. So if we look at our iPad before, we see that it's supposed to give 28, so that's good. But here it seems like we have list index out of range. Oh, I must have hard-coded something real quick. I equals M. Oh shit. Oh, sorry about that. I had a typo and I put an I instead of a 1, which is why it did not work. Let's run the code real quick. All right, cool, awesome, it works. And now if we submit it, and it works. All right, cool. So basic dynamic programming, pretty classic, and yeah, I hope you learned a lot from it. And yeah, see you at the next question. Thank you.